Hi everybody, welcome back. We're going to work on polynomials some more today. So what we're looking at here is we're doing multiplying polynomials today, and then we'll wrap up with division of monomials before we finish up this video, so that'll be at the end. I've talked in previous videos about how when we're multiplying two things by 3 or 3 by 3 or 3 by 4, that it can be easy to get lost and that we don't really have the FOIL method anymore because we have more than 4 terms that we're multiplying. So in a situation like this, it's easy to get lost because there's so many terms. So what I like to do with these ones is I like to write one extra step where I'm kind of mapping the work that I'm doing rather than leaving it to, all the geography. I'm going to write it out like this, and so that -1 is right here, and this way I'm not going to get lost. I've got a map that will help me to get through it, okay? Because now we don't have to think, okay, that and then that and then that, and do the same thing with the one. We just distribute, so it makes it a lot easier. So if we distribute this, we get 2x to the power 4. Okay, so remember, this x has a 1 on it. That's the exponent on that x. And that x has a 3 on it. So that 1 plus that 3 makes 4. When we multiply bases, we add the exponents. All right, so you'll see that going through this. So we get 4x cubed, that times that. Then we get plus 10x squared and minus 6x. Now, this -1 will get multiplied through, so we're going to get minus x cubed plus 2x squared, because these two negatives will multiply to make a positive, then minus 5x, and finally plus 3. So you see how many terms there are, okay? And this is why it's easy to get lost if you don't kind of map it out to start with. Okay, now we've got one term to the power 4, so that will be written up front. We've got 2 terms to the power of 3, so these are like terms that we can combine. So -4 minus 1 is -5, so that takes care of those. So we're going to just cross out the ones we've dealt with. Then the next is my square terms, because we like to go in descending order of power, so the highest degree term comes first, and we go down from there. It doesn't mean we'll have them all, so in some cases I might do something like this and not have any squared terms, but we still go in the order that we've got. So we've got plus 10 plus 2 there, which gives us plus 12. So those two are done. -6 minus 5. If you owe your friend $6 and then you borrow another $5, you owe your friend $11. You're down 11. So sometimes with adding and subtracting negatives, it helps to think about money. Most people understand that. So -6 minus 5 is -11. Those are gone. And there's only the one constant, and so plus 3. Just tap that onto the end. So that's it. Okay, that one is done. All right, then let's look at the next one. So we've got... So again, with this one, we have more than 2 terms. It's more than foiling. It's more than 2 terms times 2 terms. It's 3 times 3. Again, very easy to get lost here. So I do suggest mapping it out first. So the 3a squared will get multiplied by everything that's in those second brackets. So will the -4a. And so will the plus 2. And now we're just distributing. It makes it a lot easier. Much more difficult to make a mistake doing it this way. So that times that will give us 3a to the 4, then minus 3a cubed minus 15a squared. And we just work across and do our multiplication. Plus 4a squared, because we have 2 minus signs, and 2 minus signs again will give us plus 20a, and then plus 2a squared minus 2a minus 10. Okay, again, lots of terms, so really easy to get lost in the multiplication process, but this makes it much easier. Okay, now we're going to combine our like terms. So the 3a to the 4th, that's the only power of 4 I have. We've got 2 terms to the power of 3 minus 4 is minus 7. We have 3 terms to the power of 2. So minus 15 plus 4 is minus 11. Plus 2 more is minus 9. So that gives us minus 9a squared. So when you're adding and subtracting these terms, just ignore the variable that's on that term for the time being. Notice I don't think about the a squared when I'm doing that math. I go minus, so here's what I'm doing. I'm doing minus 15, what do we have, plus 4 plus 2. I don't even think about the a squared when I calculate what the coefficient is, okay? So minus 15 plus 4 is minus 11, plus 2 is minus 9, or negative 15 plus 6. Okay, I've talked in previous videos about how to deal with number line stuff. So the difference between 15 and 6 is 9. When we have one positive and one negative number that we're adding, subtracting, we find the difference between the two numbers. The difference between 15 and 6 is 9. And that's going to be our answer, except that our answer will carry the sign of the larger of the two numbers, okay? So that's all you do. And then you just tack the variable onto it that you need to have on there, okay? So that's our a squareds. So those are dealt with. Now we've got, what, 2 a terms. 20 minus 2 is 18. And finally, we finish off with that single constant, which is minus 10. And that one is fully multiplied out, okay? All right, next one. Okay, so for this one, we are going to leave this alone for the time being before we multiply any of that through what we have here. We essentially have 2 things that are being multiplied ultimately. We've got this bracket here and this bracket here, but there's a lot going on inside this bracket that we have to deal with first. So again, remember those BEDMAS rules, right? We always do what is inside the brackets first, okay? So the 3x, now we can't do anything with those because they're different sorts of terms, so we can't add them even if we wanted to. So the 3 can't be added to anything here because we have to do multiplication first. So this multiplication has to happen before we add that 3. So I'm just going to go 3 plus, and I'm going to bracket this. I don't really have to because there's a 1 in front of here, and because this is a plus sign. So the brackets actually aren't going to change anything, but I'll bracket anyway. And this is foiling because I've got 2 binomials. So we get 2x squared, and we get minus 2x there, plus 4x there, and minus 4. Bracket, square bracket. All right, so math is a very persnickety, picky subject. If you start dropping negatives, start dropping brackets, if you're not careful, if you're not neat, it's way, way, way more likely that you're going to make a mistake. And it's probably going to be a silly mistake. So really be very precise with everything that you're writing out, okay? So we're going to write the 3x minus 5 again because I'm not ready to deal with it yet. We're going to put those square brackets again. We're going to go 3 plus, and I'm going to drop these brackets now because I don't really need them. These 2 are like, so I'm going to combine them. That's going to give me 2x and then minus 4 to finish off. I'm going to rewrite this again. And now I'm going to put round brackets around this one because I don't need square brackets anymore. I don't need 2 sets of brackets. And I'm going to write them in descending order of power. So I'm going to put the 2x squared up front, then the 2x comes next, and they're dealt with because we don't have any other terms to combine them with. And 3 minus 4 is minus 1. Now again, we have more than just foiling because this is 3 terms. So we're going to map this. Now you may find down the road that you don't need to map it. If you never get lost doing this, that's great. And I certainly don't say that you have to always do it, but it does make it less likely you'll make a mistake if you map it first, okay? So 3x, this has to get multiplied by all of that, and so does the minus 5 have to get multiplied by all of that. So all I've done is written it out in a way that makes it easier to multiply. So now we're distributing. We get 6x cubed plus 6x squared minus 3x. And then this negative 5 gets multiplied by all three of those terms, minus 10x squared minus 10x and plus 5, because a negative times a negative is positive. Okay, we're almost done with this one. So now the 6x cubed, that's the only cubed term we've got. The squared, we have 6 minus 10, which is negative 4. And then just pop that x squared beside it. Minus 3 minus 10 is minus 13. Okay, when you've got two negatives that are being added, just ignore the negatives for the time being, add the numbers, and then stick a negative in front, and that'll always work. And then finally, we have plus 5. Okay, so did I get everything? I got the x cubed, I got the 2x squareds, I got the 2x terms and the constant. Okay, so that's the final answer for that one, all right? Now I'll finish off today with multiplying, multiplying monomials and dividing monomials. So let's start with this one here. This is pretty simple stuff, right? You just find the common elements. So 4 and 7, same kind of thing, is 28, multiplying of course, and x times x squared is x cubed. And that's it, that one's done. And sometimes they get a little bit longer. Okay, lots of textbooks use variables other than x and y. And it's perfectly fine. I love x and y, I like to stick with those, but when you see s's and t's, remember that s's can often look like 5, so really watch how you're writing them. And t's can look like plus signs. So I always put a little hook on my t, and it helps to differentiate it from a plus sign, okay? All right, again, we're going to look for common elements. So 8 times 4, 32. R cubed, there's no r here, so the r is just going to stay cubed. S squared times s cubed is s to the power of 5. Now see, that looks like a 5, doesn't it? So let's make that look more like an s. There we go. Okay, so remember when we're multiplying bases, we add the exponents, right? And then our t's, we have a t times a t, 1 plus 1 makes t squared. And that's that one done. And then dividing monomials. You know, when you're dividing things with exponents, here's one way to look at this. First of all, the 24 divided by the 6, that gives us 4, right? What's x cubed divided by x? What we do is we subtract the exponents. So this 3 minus that 1 gives us x squared, okay? Now, isolating those x's for a moment, here's what we've got. We've got 3 x's, x cubed, divided by x. Well, what do we know about those two x's, or those two if you will? It doesn't matter which ones we pair up. They go away, right? They cancel out. I know you guys love to cancel things. Everybody does. Be careful about canceling, but here it does work, right? So this is 4x squared because 3 minus 1 is 2, okay? How about this one? All right, again, we're going to look for common elements. Now, when you see a negative sign, I've said this before, if you see a negative sign, little flag should go up. You need to take a little extra care when you see a negative. So that negative means that my answer will be negative because I don't have a second negative. So if I was dividing two negatives, they'd cancel each other out and I'd end up with a positive. Because when you divide a negative by negative, just like multiplying a negative times a negative makes a positive. But this answer will be negative because anything negative divided by anything positive will be negative. So 36 divided by 4 is 9. There's nothing to simplify the x with, so it simply stays as x. And then the y squareds, guess what? They go away, they cancel. Okay, so that's going to be my final answer. And then the last one we'll look at. Okay, so for this one, again, we look at common elements. Now our answer is going to be positive because a negative divided by a negative is positive. So 27 divided by 3 is 9. A squared divided by A is just A, right? Okay, because you've got 2 minus 1. The b's just cancel out entirely. There's not going to be any b's left in our final answer. And then the c is 4 minus 2. And so we have c squared. And that's our final answer there. Okay, that's it for this video. Thanks for watching. If you like the video, please give me a thumbs up, subscribe to my channel, and stay tuned for lots more math topics coming up in the future. Okay, thanks for watching.